Imagine constructing a complex object with 15 optional parameters. The constructor call is a wall of arguments nobody can read. Was 30 the timeout or the max retries? Builder pattern, the elegant solution that makes complex object creation readable, safe, and self-documenting. Builder pattern, low-level design, day 9. Here's the problem. You are building a server configuration in Go. The constructor takes host, port, timeout, max retries, TLS-enabled certificate path, log level, max connections, read timeout, and write timeout. That is 10 parameters. And Go has no default parameters, no named arguments, and no method overloading. Every caller must pass all 10 values even if they only care about host and port. The function call is unreadable. New server of localhost 8080.30.3 true empty string info 100 5 10. Nobody can tell what 30 means without checking the function signature. Was it timeout or max retries? Even worse, you can silently swap 2 integer arguments and the compiler will not catch it. And if you need to add an 11th parameter later, every single caller must be updated. This is called the telescoping constructor problem, and it gets worse with every new option. The builder pattern solves this with a step-by-step construction approach. There are 4 participants. First, the builder interface or struct. It defines methods like setHost, setPort, with timeout, with TLS, and a build method that returns the final product. Second, the concrete builder. Server builder implements the builder with internal state. Each setter method stores the value and returns the builder itself, enabling method chaining. Third, the product. The server struct is the complex object being constructed. It is created only when build is called after all configuration is set. Fourth, optionally the director. A director encodes a particular construction sequence. For example, a production server director always enables TLS, sets high timeouts, and configures logging. The key insight is separation of construction for representation. The same builder can construct different configurations. Required parameters go in the constructor. Optional parameters use fluent with methods. The build method can validate before creating the object. Here is the builder pattern in Go. First, the builder struct. Server builder has fields for host, port, timeout, TLS, and max connections. The constructor new server builder takes only the required parameters, host, and port. It returns a pointer to server builder with sensible defaults for everything else. Now the Fluent API. Each with method takes a value, sets it on the builder, and returns the builder pointer. With timeout sets the timeout and returns the builder. With TLS sets TLS and returns the builder. With maxCon sets max connections and returns the builder. The build method validates the configuration and returns the final server struct. Here is the usage. New server builder of localhost 8080. With timeout of 30. With TLS of true. Build. Every call is self-documenting. You can read exactly what is being configured. Adding a new option means adding one new with method. 0 changes to existing callers. Builder is one of the most common patterns in production code. First, HTTP clients. Every major HTTP library uses Builder. Go's http.newRequest, Java's OKHTTP-request.builder, Python's request library, uchain URL, method, headers, body, and timeout. Second, SQL query builders. Select.from.where.join.orderby.limit.build. Libraries like Squirrel in Go, JWQ in Java, and Connects in JavaScript all use this pattern. The query is constructed step by step and validated at build time. Third, UI components. Android's alert dialog.builder is the classic example. Set title, set message, set positive button, set negative button, create. Every Android developer uses this daily. Fourth, configuration objects. Server configs, database connection pools, gRPC channel options, Kubernetes resource specs. Any object with many optional settings benefits from Builder. The pattern is so fundamental that most modern APIs are designed as builders from the start. People confuse builder with constructors and factory method. Here is the clear distinction. A regular constructor takes all parameters at once. New server of host, port, timeout, TLS. Use constructors when you have few required parameters, typically 3 or less, and no optional ones. Factory method creates one product type based on a type parameter. New notifier of email returns a notifier. The type varies, but the configuration does not. Use factory when you need different implementations of the same interface. Builder constructs objects step by step with a Fluent API. New server builder of host port.with timeout of 30, .with TLS of true, .build. The configuration varies, not the type. Use builder when you have many optional parameters, when the object needs validation before creation, when you want the same construction process to create different representations, or when building immutable objects that need complex setup. The decision rule: fewer than 3 parameters, use a constructor. Type varies, use factory. Many optional configuration parameters, use builder. If you have more than 3 or 4 optional parameters, builder almost always wins. When to use builder in interviews. Complex objects with many optional fields. Immutable objects that need step-by-step setup because you cannot set fields after construction. Object creation that needs validation. The build method checks everything before creating. Same construction process that creates different representations. Red flags that scream builder pattern. A constructor with 5 or more parameters. Multiple constructor overloads trying to handle different combinations. Boolean parameters that nobody can understand at the call site. Objects that can be created in an invalid state because there is no validation step. Common interview questions. Design a query builder for SQL. Query builder.select.from.where.join.orderby.limit.build. Design an HTTP request builder. Request builder.url.method.header.body.timeout.build. Design a meal ordering system. Meal builder.setMain.setSide.setDrink.setDessert.build. The pro tip is to show the Fluent API with method chaining. Mention that build performs validation, and if the interviewer asks about complex construction sequences, introduce the director pattern on top of builder. 5 things to remember. Builder separates complex object construction from its representation. Step by step, not all parameters at once. The Fluent API uses method chaining, where each with method returns the builder itself. This makes code readable and self-documenting. Constructor for few parameters, factory for type variation, builder for many optional configuration parameters. This is the key decision framework. Real-world uses are everywhere. HTTP clients, SQL query builders, UI dialog builders, configuration objects, gRPC options. And in interviews, if you see 5 or more parameters or complex setup logic, suggest builder immediately. Show the Fluent API and mention validation in the build method.